Hello students, so far we discussed relations, different types of relations, then representation of relations, how to find domain, codomain and range of a relation. Also solved some problems in previous classes based upon whatever we discussed so far. You try to solve more problems. If any doubts you are finding, you post in comment section. Today after relation, we will discuss function. What is a function? Function is nothing but a special type of relation. Which type of relation it is? Let us take two sets A and B. A function f symbolically will denote a function f from set A to set B is a we will write mathematically like this f this dot A to B, it means we will read like this f from A to B. So f from A to B, a function f from A to B is a relation when it will be a function is a relation. Which type of relation it is? If each element of set A is sorry if each element of set A has unique image in set B. So that means if A from A to B is a function, then for let us take a element, say small a belongs to your capital A set, A, small a belongs to A, f of A equal to B. F of A equal to B. What is B? B is from set B. And this B is the image of A. This B is the image of A and this B is the unique image of the element A. In other words, f is a function from A to B if every element of A has image in B and the image must be unique image. Means each element you can take, whatever element you can take from set A, it has a image in set B. All elements, each element. Then for each element of set A, it has a unique image in set B under this function. So this function is a relation, but it's a special type of relation. Which type of relation? First of all, each element of this set has an image in set B and the image is an unique image. The image is an unique image. Means each element of set A has a unique image in set B. If this condition is satisfied, then a relation is said to be a function. So means in other words, function is a special type of relations. You will be more clear through examples. Let us consider an example. Today's first example. Let set A containing elements a relation R from A to A. R stands for relation, F stands for function. R from A to A is given by R equal to collections of all the ordered pairs x y such that this y equal to x plus 1. In this way, the x and y are related. Y equal to x plus 1. So here R is a relation. You have to check whether this relation is a function or not. Whether this relation is a function, because you know function is a special type of relation, and also I discussed which type of relation is said to be function if each element of set A, that is called domain, has a image in set B which is your codomain of the function, and each image is unique. Means one element cannot have more than two images in the codomain set. So to check R, the relation R, you can write here the relation means R is a relation, it is given, you have to check whether it is a function or not. The relation R is a function or not. So you know how to represent a relation. A relation can be represented in two ways. It can be represented by what? In set builder form or in roster form. So individually we can write here R in your roster form. So that means because your set A, domain set, here domain and codomain both have your set A, and set A is having elements 1, 2, 3, 4, 5. When first element x equal to 1, when your first set x comes from your first set. Here first set, second set means domain, codomain both set. So when x equal to 1, what is your y? X plus 1, that is 2. So your R is the collections of ordered pairs 1, 2. When x equal to 2, y equal to x plus 1, so it is 2, 3. When x equal to 3, then x equal to 3, 3 plus 1, that is y 4. So next is 3, 4. Similarly 4, 5, then 5, 6 up to this. But why not next? When if you will consider 6 here, 6 plus 1, 7, y will be 7. 7 is not in set A. Is 7 is in set A? No. Because here codomain both set A, means all the elements of x are in set A. All elements of y also are from set A. So if it is x equal to 6, then y will be 7. So 7 is not from A set. So in this case you are getting this relation. Now you see, is the relation is a function? No, it's not a function. Why it's not a function? Because while defining function, we discussed that each element has an image and that image should be unique. But you see, 6 has no image in your codomain set. 6 has no image in your codomain set. So here you will write R is, the relation R is not a function. Reason you write. Why? Because as the element 6 has no image in set A. So next, we solve some more examples so that you will be more clear. Next, example 2. Let us define a relation like this. You know, you can represent a relation in set builder form, in roster form, also in pictorial form, graphical also you can represent. Suppose you are given a relation in graphically. Given a relation R like this. relation R from P to Q. Here this is P set and this is your Q set. The set P containing elements say 9, 4, 25, and the set Q containing elements such that 3, minus 3, 3, then minus 2, 2, then 5, minus 5. It is given like this. So 9 has suppose image 3, 9 has image minus 3 and 3. Say 4 has image minus 2, 4 has image 2, 25 has image 5, 25 image minus 5. Now you see, is the relation a function here? No. Why it's not a function? Because the element 9 has 2 images. Element 9 has 2 images, more than one image. It has no unique image in set Q. The element 9 from set B has no unique image in set Q because it has 2 images. One 9 goes to 3 minus 3, another is 9 goes to 3. Similarly 4 has also 2 images, minus 2, 2. 25 has 2 images, 5 minus 5. So means elements of set P has no unique image in set Q. So therefore you can write R is not a function. Reason you can write, since elements, you can also write each element, since each element of set P has no unique image in set Q. Therefore, the relation R is not a function. Yes. Now one remark or note you can write here. You can say also, is all relations are functions? And converse also true? Yes, we can say all functions are relations, but not all relations are functions, not vice versa. The note you write down, all functions are relations. All functions are relations, but not all relations are functions. Now you see, here we proved also from example 1 and 2 that both are relation but not function. In previous example we found that all the elements of domain set has see one element of domain, sorry, here the previous example we found that one element of from domain set has no image in codomain set, and here in example 2 we found that the elements of from P set has no unique image in your codomain set. So therefore these two are relations but not functions. You can solve more problems so that you will be more clear. If any doubt you are finding, you post in comment section. While defining our function relation, you are finding your domain, codomain and range. Here also you can find domain, codomain and range of a function. See, you know, if f from a to b is a function such that f of x equal to y, this x belongs to your set A, y belongs to your set B. Then this first set A is your domain of the function, This second set B is the codomain of the function, and all the images, if we are collecting and forming a set, then this is your range set. Means here f of x equal to y, y is the image of x, y is called the image of x. If f of x equal to y, then y is the image of x. See here, since f of x equal to y, that means y is the image of element x. Now your range of the function is nothing but collections of all y such that y equal to fx. One thing you can add here, this x comes from your domain set. So whatever elements you are finding from your domain set, if you are finding its images, that is your y. Now the collections of all the y is your range of the function. Thank you.